Hello everybody, my name is Mridul and today we are going to discuss a topic which is called control system. So basically this is a brief session on how to prepare for control system for gate. Okay, so as we all know that this subject is very important and it is therefore in three streams, for example EE and ECE and IN, and more or less in all these three streams the syllabus is almost same. Okay, and the marks that we can expect from control system, okay, so this is all about control system, so we can expect around 10 marks from this subject in any of these streams. And we know that out of 100 marks in GATE, if we get a subject which is about, or where the weightage of the subject is around 10 marks, so it's very important. Okay. And one more thing is that this subject is also easily scoreable subject. Okay. So today in this particular session we are not going to get into the topics, rather we are going to discuss how to prepare this topic for GATE, or what are the topics that is required to prepare for GATE. Okay, because we know that control system is a very vast subject. Okay, whereas the requirement or the scope of this particular subject for GATE is not much. Okay, so let us understand in this particular session what is the requirement or what is the syllabus of this subject for GATE. Okay, so first of all, before I start, let us first of all understand what is control system. Basically, control system, as we understand from the word, is we need to control system. Now the question comes in mind, why do you want to control system? This is something which we have to understand. We need to control something basically when we need to automatize this. Okay, so this subject, okay, was developed, okay, in the early 19th century, okay, onwards. There are various different sectors in which theories were developed. For example, there were sectors of process control industries where the technique was developed. Also there were servo mechanics during the Second World War, where this concept was developed to automatize the artilleries, okay, which was called servo mechanics, or the machines. Servo mechanics means the machines are our servants, okay, in that concept. So there was this theory was developed, servo mechanics theory was developed during that period, and gradually there are other theories which were developed, and all of them were merged together, and this subject was formed, which is called control system. That means generally the idea is, if we have a system, how do we automate the system? Now, the thing is, it's very important for us to understand what is there in GATE. Okay, since I have already said that control system is very vast, we have to understand what are the different areas, or what are the different techniques to control a system or study a particular system. So first thing we have to understand is, to automatize a system, we need to study the system, as simple as that. So how do you study a system? Now here also there are different techniques to study a particular system. One simple way to study a system is mathematical approach. Right? Now what is mathematical approach, or what is mathematical study? Mathematical approach means, let us take an example. Let us say there is a body of mass m and it is resting on a plane, and if I apply a force F as an input, it will experience a frictional force F. Okay, and if this force, input force, is more than the frictional force, this body will move in this direction, and the displacement x is the displacement of this particular body. Now this is a system where we are giving some input and we are getting some output. Okay, so if we give some input and the particular system responds, then it qualifies for us to study the system, or we can call that as a system. So here we are giving some input and we are getting some output. Okay, so how do we express this? To express this, we can write force, input force minus frictional force is equal to mass into acceleration, or we can write d2x by dt squared. Okay, now this particular equation or this particular technique of representing a system by a differential equation is called mathematical representation of a system, right? And this is why we study differential equation in the syllabus. I mean, in mathematics, we have this particular course which is called differential equation, right? So this is why we study this in GATE. Okay, so this is important. Now, once we have, now this is the second order differential equation. Now, similarly, we can have first order, second order, third order, fourth order, different order systems. Moreover, not only mechanical system, any type of system, for example, electrical system, a RC network, series RC network, is nothing but a first order system. A RLC series network is a second order system. So, in that way, not only mechanical or electrical, for example, other systems like pneumatic system, hydraulic system, etc. Okay, or combination of these systems can also be expressed mathematically. Now, this technique to express the systems into mathematical expression is called mathematical representation of a system. Now, here we have to understand that this particular technique is not required as such in GATE. Okay? What is required? Then what is required in GATE? That means, what from the point from where we will start is, we will have a mathematical representation. Mathematical representation. Suppose we have a mathematical representation of a system, which is nothing but a differential equation, Okay. Now, this mathematical representation can be of a mechanical system, can be of an electrical system, or any other system, or combination of systems. Okay. We don't have to care about that. Now, what we need is, once we express this as mathematical representation, then what we need to study, how to do that, what is the study about. So this is all about the syllabus of GATE, which starts from this particular point. Okay. Now you see, now when we have a system, what do we study for that system? How to study? I mean, what do you need to study? So basically, the things that we study is, first one is, whether the system is stable or not. Second one is, what is the speed of the system. Third one is, how much accurate the system is. Okay. So these are the basic parameters which, depending on which we can judge a particular system or study a particular system. So how do you get this? Okay, so this is what we will learn. Okay. Now, mathematical representation, to study mathematical representation, what we do is, there are two approaches. Okay, there are two approaches. First approach, which is very, very important in gate, is known as transfer function approach. Transfer function approach. Second approach which we have to study for gate is state space approach. Now, what is the difference between these two approaches? Basically, this transfer function approach is an approximate approach. Approximate means we take some approximations in this while doing this analysis or in this particular approach. First approximation that we take is that only linear systems can be analyzed with this particular approach. So linear time invariant LTI system, which we know as. Only LTI system is appreciated in this particular approach. Second thing which is very, very important again is that the systems are expected to be at rest, or initial condition. Initially, system is at rest. System is at rest. So these are the two most important approximations that we take in this particular approach. Whereas state space approach is a accurate approach. Okay, we don't take any assumption in this particular approach. So this is accurate. Okay, first thing. That means the system can be linear, it can be non-linear. If there is some initial condition, that also we will consider. So these are the things which we will not consider, we will consider in state space approach. One more thing is, in transfer function approach, we go for single input, single output system at a time. Okay, we cannot have double or multiple input, multiple output at a time. Okay, it's not that we cannot analyze, but it becomes very complex for multiple input, multiple output system to analyze in transfer function approach. Okay, it is possible, it's not that it's not possible, but it becomes complex. Whereas in this particular analysis, multiple input, multiple output is simple. Okay, it's simple. Okay, so that is also one benefit of state space approach. Now let's talk about gate. Now with respect to gate, if you see the distribution of marks, this topic has a weightage of around 2 to 3 marks. Okay, and the number of topics in this particular approach is also not much. There are 5 to 6 topics which you have to study in this particular approach. Okay, so this is just, these topics which we have to study are just the basics of this particular topic, okay, to give us an idea what is state space approach. Whereas transfer function approach, you can expect around 8 marks from this. Okay, it's very, very important. And also the number of topics in transfer function approach is very high, or more. I mean, very high means the number of topics here is more as compared to this. So this doesn't mean that this topic is not important. What I'm saying is the number of topics here is less, but definitely you will get a 2 marks question from here, at least. Okay, whereas here the number of topics are more. Okay, so we will see what are the topics and why, and what is the importance and what is the necessity of each and every topic here. So we will see the number of topics. Coming back to transfer function approach, and in this approach what we do. So as we know, or even if you do not know, what is transfer function? Transfer function is nothing but it's a relation between input and output. That means we take the Laplace transfer of output by input, and that ratio is known as transfer function. Okay. Now, this transfer function approach, okay, again can be divided into two parts. And this is important. Now, what are the two parts in this transfer function approach? First one is time domain analysis. Okay, time domain analysis. And other one is frequency domain analysis. So time domain analysis and frequency domain analysis. Now we know that we need to study the stability of a system, speed of the system, and accuracy of the system. Now, what is the difference between time domain and frequency domain? Now, these are two different analyses which we do for transfer function approach. For example, if we have a mathematical representation, okay, that means relation between input and output, from there we can find out the transfer function. Once we have the transfer function, then we can analyze that particular system in time domain, or we can do in frequency domain. That means, what is the difference between time domain and frequency domain? The simple difference, if I can tell you, is that in time domain, the input that we give are time dependent. For example, inputs are u of t, that means unit step input, del t, impulse, or ramp input are t. So if these types of inputs are given and we analyze, then if these types of inputs are given to the system and we analyze, that is called time domain analysis. If we give sinusoidal input, okay, if we give sinusoidal input, that means either sin omega t or cos omega t, okay. If we give sinusoidal input to the system and we find out the response or analyze the system, that is called frequency domain analysis, okay. Now, how do we do that, and what are the things that we do? So what we do here is time domain analysis. So there will be a response, right? So when we give some input, we get some output. Okay, that is called the response of that particular input. So that response can be again divided into two parts, which we all know. That is transient and steady state. Transient and steady state. Okay. Now, speed. Now let us understand. Now from here we can understand what are these things. Okay. First thing is stability. What is stability? When can we say that system is stable, and when can we say the system is unstable? Now we all know, like, some standard definitions like BIBO, which is bounded input. If we have a bounded input, we get bounded output. So all that is fine. But practically what we mean to say is, suppose we give some input, okay, which is bounded, of course, but our output goes to infinity, okay. So that is called unstable system, basically, by definition. Actually what happens? So actually what happens is, as we give some input, as we give some disturbance, okay, some transients are produced in that particular system. Now, these transients will either die out as time increases, or this transient will increase as time increases. If the transient dies out, the system is stable. If the transient increases, system is unstable. Now what will happen if it is in between? That means the transient does not increase, but it does not die out. Okay, it can happen, right? So that particular system is called marginally stable system. Okay, marginally stable system. That means the transient is not becoming unbounded. Also, even if it is bounded, but it is not dying out. So that is called marginally stable. So stable, unstable, marginally stable, all depends on the transient nature of the system. Now here is something which is very, very important. That one thing we have to understand, in my later videos I will go in depth with that particular topics, and we will again focus on those concepts. But for now I would like to tell you something like, if a system is unstable, then it does not matter what input you give, okay? Whatever input you give, whether you give bounded input or unbounded input, definitely the system will go to infinity. So definitely the system will go to infinity as time tends to infinity. Okay? So that means what? The behavior of the system, okay, the behavior of the system does not depend on the input of the system. This is a very important thing. Okay, this is a very, very important concept. So behavior of the system does not depend on the input of the system. It depends. So that means what? In what thing does it depend? So it depends on the transfer function or poles of the system. Okay, or poles and zeros of the system. So what is poles and what is zeros, and from where these things are coming? So gradually in the next topics we will see. This particular session I just want to put things in place, which are the topics we are doing and which comes under what, so that you get a very clear idea. So this is what you need to do, and then we will start with explanations. Okay, so up to here we got it, right? So now transient. So we know that when you give an input to a system, okay, then the response will have two parts: transient response and steady state response. So in transient response, okay, we can find out the speed of the system. That means how fast the transient dies out. That is called the speed of the system, right? So speed of the system can be studied here. Whereas accuracy means once it reaches the steady state, what is the error of the system? That means what is the error between the input and the output? That is called accuracy or error. Okay, so error we will see in steady state part. Okay, steady state part. So these are the two things. Now stability, how to find out stability is, we will see in next video that stability actually is nothing but it depends on the poles of the transfer function. If a pole is on the left hand side of the S plane, then what happens is the transient that is produced is decaying in nature. Okay, so if it is decaying in nature, what happens? The system becomes stable, as simple as that. But if a pole is on the right hand side, why? Because see, suppose a transfer function is there. Transfer function is something like 1 by s minus 2. That means s minus 2. Okay, so this is the denominator, and if I solve the denominator, I will get s is equal to 2. So 2 is a pole of the system. Now this pole is on the right hand side of S plane. Isn't it? That means if I draw the S plane, 2 is on the right hand side. Okay. Now if I take Laplace of this, okay, Laplace inverse of this, so it becomes e to the power 2t. Now e to the power 2t means it increases with time. Okay, the value increases with time. So that means the type of transient that this system is going to create will increase with respect to time, and thus it will make the system unstable. Okay, it will make the system unstable. So stability of a system depends on the poles of the transfer function. This is a very, very important concept. Now further, we'll do further analysis, how to find out the poles of the system, and if the order of the system increases. For example, if we have first order, we can easily find out the pole. If it is a second order, then also we can find out the poles. What if it is higher order? That means third order, fourth order, fifth order. sixth order. How do we find the poles? We don't know how to solve. Mathematically, by computer simulations we can do, or MATLAB we can do, but manually it's very difficult to solve a higher order system. So there are some shortcut techniques which is known as Routh-Hurwitz criteria. So to find the stability of the system, we will study Routh-Hurwitz criteria. Okay, Routh-Hurwitz criteria. So that is a technique, without solving the characteristic equation of the denominator of the transfer function, we can find out the poles, we can comment whether the system is stable or not, as simple as. Now, next thing what is there is root locus. So root locus basically is a technique to design a system. That means the roots or the poles of the system, if it depends on a constant, okay, or if it depends on a variable, that means if we vary that, okay, if we vary that, the poles are going to vary. So that means I can design my system, or I can decide where my poles should lie. Okay, so root locus is a technique by which we can see that if we vary a particular constant or a particular variable, if we vary it from 0 to infinity, where my poles will lie. Okay, now according to that, we will see where do I want my poles to be. So at that point, I will find out what should be the value of that particular constant. So that is called root locus, or that is the purpose of root locus is to design a particular system, right? So root locus techniques also we will study after this particular topic. So that is all about time domain analysis, or we cannot exactly say that root locus is a time domain technique, but we don't give any input also. Okay, so basically root locus is all about systems and its behavior. Okay, we are not giving any input there. Next thing will be frequency domain analysis. Now in frequency domain analysis, what we study is basically the stability of the system. Okay, so there are techniques, for example, polar plot, Nyquist plot, and Bode plot. So these are the three important topics which we will study in frequency domain, and also later we will see what are the advantages of these particular techniques. So this is all about transfer function approach. This is all about we need to study. After that, there is a small topic which is called controllers and compensators. Okay, so controllers and compensators is just the introduction of controllers and compensators is required for gate. I'm not saying that controllers and compensators is a small topic. It's itself a branch. Okay, but as far as gate is concerned, controllers, the importance of controllers and compensators is very, very small. You can say you can expect a 1 marks question, or very rare you will get 2 marks questions from compensators. And controllers, it's nothing different. Whatever we are studying in this particular analysis, here we can indulge the name of controller in between any topics. Okay, so we can merge controller concepts in any topics. Okay, so we will also see what is controllers. For example, P controller, PI controller, PID controller, which is very simple concept, nothing much to worry about that. So we will learn it, and then we can merge that concept in any of this, but any concept here. Okay, whereas compensators is a topic where there are few formula based questions. Chances are there that you will get some formula based questions. For example, if there is a lead compensator, what is the maximum phase lead that you can get from that particular compensator. So there is a formula, and you just if you go through that, that's fine. Okay, that's it. So after that, we will do the state space. So in state space, basically the finding the controllability and observability is the most important topic in this particular state space. So I hope I have covered almost all the topics that is required to study in this syllabus of GATE, okay, which we require to study for preparation of GATE. So in my next videos, I will try to cover one topic at a time and how to prepare for each of these topics. So till then, best of luck and prepare well, okay. And you can comment on this particular video, and if I am wrong somewhere, please let us know, and that's all. Okay, thank you.